Welcome back. The next topic is geometric sequences. It says, what do these sequences have in common? If we look at each of these sequences, we can see that there is a common multiplier, which we actually call R. If I look at letter A, I notice that we're multiplying by 2 each time to get each term. And if you have a common multiplier, we call it a geometric sequence. If I look at letter B, you might not see it right away. The signs are alternating, so that means my R value will be negative. And if I multiply 4 by -1/2, I will get -2. You might be thinking, oh, I'm dividing by 2. Well, remember, dividing by 2 is the same as multiplying by 1/2. The next one, letter C, 4 times what gives you 8/3? 8/3 times what gives you 16/9? Well, when I look at fractions, I just think, what do you multiply the numerator by to go from 8 to 16? That would be a 2. And what do you multiply the denominator by to get from 3 to 9 or 9 to 27? 3. Letter D, again, I'm seeing alternating signs, so I know my R value will be negative. In this case, it's -2. If you can see it, you have number sense with computation, great. If not, it says, how do you calculate R if you cannot see it right away? And R is a non-zero ratio. Ratio is a good word, and that's why we use the R to help you remember how to find it if you don't see it right away. If you take any term and divide it by the previous one, you create a fraction or ratio, which will give you the R value. Even here, if I take 16/9 on my calculator and divide it by 8/3, I will get my R value of 2/3. The technical way of writing it is that every R can be found. Oops, not showing up so well there. Let's do it down here. Every R can be found by adding a term and the one before it. This is how it's written in our textbook. However, you could always say a term and the previous, as long as you're not going back and doing one before the first one. So it's any term and the one before it. That's a geometric sequence. Let's go on to our examples. Example 1, which of the following sequences, I should say is, because there is only one, is geometric. If I look at the first one, you might look at that and think, I don't know what you multiply 3 by to get 5.1, or 5.1 by to get 8.67, or 8.67 by to get 14.739. We'll use your calculator. Simply take any term and divide it by the one in front of it. And when I do this on my calculator, I get 1.7. I will get the exact same thing when I take 8.67 and divide it by the 5.1. I will also get the same thing when I take the 5.1 and divide it by the 3, making this geometric and making my common multiplier 1.7. If I look at the next one, if I take 16 divided by 9, I do not get the same thing as I get when I take 9 divided by 4 or 4 divided by 1. So this one is no, not geometric. Number 2, I'm going to try to derive the formula for a particular term. If I notice here, this is geometric. We're multiplying by 3 each time. So the first term will always be your first term, whatever that happens to be. In this particular one, it's a 2. The second term is I need to take that first term, which was a 2, and I multiplied it by 3, which was my common multiplier. To get my third term, I took my second term, which we said was a sub 1 times r, and multiplied it by another r. Then when I got my fourth term, I took what my third term was, which was this guy right here, and multiply it by another r. To get my fifth term, I'm sure you're seeing the pattern now, I take my fourth term and multiply by another r. So we all know that exponents are a way of writing repeated multiplication. So if I look at the fifth term, it was a sub 1 times r to the 4th power, because there were 4 r's. In this one, 3 r's. In this one, 2 r's. If you notice, the relationship between the term and the exponent is that the exponent is always 1 less. which makes our formula for any term in a geometric sequence a sub n equals a sub 1 times r to the n minus 1 power. Please add that to your pink sheet on the third one. And our last example for this video, example 3, find the nth term, 10th, and 15th term of the geometric sequence. So if I look here, first thing I like to do is always refresh my memory with the formula. If I look at this one, if I need the nth term, my first term is a 4.6. It looks like my r value is a 2 and n minus 1 power. Please get in the habit of using parentheses around your r value because if it's negative, your calculator will need them. Next, for the 10th, I will plug in a 10 for n, type that into my calculator, and I get 2355.2. And for my 15th, I do the same thing. Use my original formula here and plug in a 15 for n. And when I do that, I will get 75,366.4. That concludes your video on geometric sequences.